These are the beginning of the notes for Unit 5 in Algebra 3. This section is 2.5, Transformations of Functions. I'm going to split this up over a few different videos. There's a lot of information coming. It's not difficult information, just a lot to think about. So we're doing rigid and non-rigid transformations. A rigid transformation just keeps the same shape and size of what we call the parent function, the original function. Translations and reflections are rigid transformations, and that's what we're going to focus on right now, is just translations. Later we'll do non-rigid transformations, and non-rigid transformations change the shape or size of the parent function. Stretches and shrinks are non-rigid transformations. Sometimes the word compression is used instead of shrinks. In Algebra 2, the SOLs expected you to use the word compression. When we're talking about translations, we're just going to shift the function. So we can shift the function either up, down, left, or right. So the first one I have is f of x plus h. That's going to shift the translation up h units. So I'll give you a few examples. If I have y equals the square root of x, and I want to transform that with y equals the square root of x plus 3. Notice the 3 is on the outside of the radical. This is going to go up 3. If I had y equals x squared to start with, that's my parent function, and I want to transform that using y equals x squared plus 7, that is going to go up 7 units. So for the function f of x transforms into f of x plus 1, I'm going to go up 1. Let's look at this graphically. I like using the square root of x function because it's not symmetrical. It's a fairly unique graph. So if I had y equals the square root of x, if I plot the point 0, I'm going to get a square root of 0 is 0. If I want to use the point 1, the square root of 1 is 1. So I'd have the 0.11. If I had a 2 or a 3, I'm going to get a decimal. So I'm going to go right ahead to my next point is going to be 4. The square root of 4 is 2. So I'm going to plot the point 4, 2. And then the next one will be 9, 3, 16, 4, and it keeps going. Now if I took this and changed the graph to y equals the square root of x plus 2, I'm going to move everything up 2. So I'm just going to take this point, go up 2, take this point, go up 2, take this point, go up 2. And this is the transformation. If I had f of x minus h, so I have this function, this is going to go down h units. So if I had y equals x cubed transformed into y equals x cubed minus 1, this goes down 1. If I have y equals the cube root of x, and I want to transform that into y equals the cube root of x, notice my cube root stops there at the x, and then minus 6, I'm going to go down 6. So f of x transformed to f of x minus 3 will go down 3. So if I go back to my square root of x function again, and I graph 0, 0, 1, 1, 4, 2, there's my function. And say I wanted to go down, let's go down 3. take everything, go down 3. That's what it looks like. So this would be y equals square root of x down 3. The next one I have has the h inside with the x. So anytime I have the number on the outside, it's going to go up or down. If I have the number on the inside, it's going to go right or left. And this is not what you think it's going to be, or you might think it. You've seen this before. This is going to go right h. Think of your factors. If you were factoring a quadratic, x minus 2 was a factor, x would equal 2. You got right 2. So to demonstrate this, I have y equals absolute value of x, and I want to transform that to y equals absolute value of x minus 2. This goes right 2 units. If I had y equals x cubed, transform that to y equals x minus 7 cubed. This is going to go right to 7. Notice where I'm putting the number. It's inside the function. The function is the absolute value. The function is the cube. And if I had f of x, transformed it to f of x minus 4, I'm going to go right 4. So if I go back to the graph of this, I'm always going to start with my square root function. And if I transform that, let's go right 2. So if I move that right 2, if I move this one right 2, and if I move this one right 2. So this would be y equals the square root of x minus 2. The last one is f of x plus h. Once again, the h is inside with the x. This is going to move left h. So if I had y equals x squared, and I transform this to y equals x plus 5 squared, that is left 5. If I have y equals the absolute value of x, and I want to transform that to y equals absolute value of x plus 1, this is left 1. So f of x equals f, do it this way, f of x transforms to f of x plus 2. Is going to go left 2. So if I graph it, once again start, I'm not going to have room if I start there. Zero, 0, 1, 1, 4, 2, and there's my square root of x. If I take this and move left 3, I move this point left 3, move this point left 3, and I move this point left 3. This is my transformed graph. This would be y equals the square root of x plus 3. So with all of these, the general shape is still the same. I didn't change the shape, I didn't change the direction, and I didn't change the size. I just moved its location. That's it for part 1.